And now we begin with our discussion on geometric sequences and series. We'll look at this by means of an example. Okay, we'll look at this sequence of numbers 5, 10, 20, 40, 80. Okay, and we will reference them by tagging them first, second, third, fourth, fifth, and so on. Okay, as you can see, each number is twice the preceding number. Each number is twice the preceding number. 10 is twice 5, 20 is twice 10, so on and so forth, allowing us to alternately write these progression of numbers. The first is 5, the second is 5 times 2, the third is 5 times 2 squared, the fourth is 5 times 2 cubed, and you can see a pattern there, whereas you might even be able to find the 10th, the 20th, the 50th, or the 100th term without having to generate all the ones preceding it, okay? Of course, when we move this out of a sequence to a series, we simply put plus signs in between them, okay? And as is usually the case, we're going to be, here's our series there, we are going to be involved, one to be asking, can you sum the first 5, the first 20, the first 500 terms of the series, okay? So to that extent, we're going to look at a way in which that is done, okay? So again, this series, as we see here, 5 plus 5 times 2 plus 5 times 2 squared is what we call geometric, okay? And it being geometric, okay, every term is some factor, is some multiple rather of the preceding term. 5 is in this case, it is twice the preceding term. So the first term is our where we build it from. That's called our A term. And the constant ratio or the constant multiple between successive terms, in this case being 2, is referenced as R. So as a general expression, as a very general expression for a geometric series, it's going to look like the sum of numbers, sum of n numbers, generated as, you know, a plus a to the r plus ar squared plus ar cubed, so on and so forth. So that being the case, if we took this this expression up here, we obviously see this is the fourth term. This is the fourth term, and its general form is a, that first term, and then the constant ratio with a n minus 1 as its exponent, where n is the term number. So since this was the fifth term, it is to the fourth power. So if I wanted to find the 25th term, then it would be, okay, and for this particular one, it would be, you know, 5 times 2 to the 24th power. Okay, rather large, but that's in fact what it would be. Now, we're going to establish a way in which we can find the total sum of a geometric series. So we're going to take this expression, which is our general form. So we're going to try to establish a method of summary of this geometric series. So as we saw, the summation takes on this form, and I'm going to propose what we do is we take this series and we multiply all terms by r. Okay, so that is the left-hand side would be r times this summation of n terms, and then each of the subsequent terms would be, the first term would be AR, the second term would be AR squared, and so on and so forth. Now, what we do in this case then is we subtract this R S sub n from the S sub n, okay? So we're doing S sub n minus R S sub n, and what happens is we get a sequence of cancellations, okay? The first term is not going to cancel out, but the A and the AR from each is going to cancel out, AR squared is going to cancel out, AR cubed, and so on down the line. So what's going to be left when we subtract these, again, on the left side is going to be S sub n minus R sub S sub n, and then on the right side we're going to be left with A, the first term, and here the last term, okay? Now, again, this is what we're left with. And if we can do a little algebra here, just pull out the common factor S sub n. And now, of course, we're going to isolate S sub n by dividing by 1 over r. And we find we have a formula for the summation. So here's our formula for the summation of any geometric term. A, which is the first term, r, which is the common ratio between successive terms, to the nth power less 1 over r minus 1. Okay, now we'll put that to the test with this series that we've been looking at previously, which we found summed up to 155. Okay, here it is again. The summation is 155. And now we're going to apply our formula, identifying A, identifying R, and putting them into the form here. We're going to want to sum up here to see that we get the 155. That's the first 5 terms. So r to the n is 2 to the 5th, which is 32, less 1 is 31 times 5. And the denominator is r, the common ratio, which is 2, less 1, which is 1. So it's 5 times 31, which is 155. 155, it seems like that's a typo. There should be 155. So what if I said, well, let's sum the first 10 terms of that series? So in other words, we want to sum up to the first 10 terms without having to generate all the 9 preceding it. Again, just using the form that we saw up here, A to the quantity times the quantity r sub n, r to the power n less 1 over r minus 1. Get that, and we get our sum is 5,115. Okay, so that's a real good formula to have right here for the summation of n terms of a geometric series. Okay, all right. Now, you will see in the exercises some problems involving sigma. You'll see these problems in both the arithmetic series and the geometric and many other series, okay? So we'll look at this. This is a notation. This is the sigma symbol, okay? This is generating an arithmetic sequence, but let's talk about what it is pretty much, okay? The k is the integer, which is taking, k is the variable taking on all integer values, beginning with the value at the bottom of the sigma and ending with the value at the top of the sigma. So, and each successive term is connected with addition, which generates our series. Okay, so it's 2 to the 2 times 1. Which is 2, and then we kick in with k equals 2, 2 times 2, 4, 2 times 3, so on and so forth, okay? So, so as we say here, the notion implies that the terms are of a series and are generated here. Now here's a different series, 2 to the power k, starting with k equaling 1 to 6, okay? We should see that's going to generate 2 to the first, which is 2, 2 to the second, which is 4, 2 to the third, which is 8, okay, and so on and so forth. So this is the terms, and those I would hope you would recognize as a geometric. So these are just alternate ways, kind of collapsed ways, more compact ways of generating series, and in more or less identifying for you basically what the nth term in the series would be, okay, just by this form. We will talk a lot more about those in the upcoming videos, but just an early exposure to them right now should do you some justice with the textbook problems, okay? There you go.